So basically when we have to find out the force on a current carrying conductor in a magnetic field, so in diagram you can see on left hand side we have north pole, on the other side we have south pole, and in center we have a conductor. And you can see there is a cross, and cross means current is moving into the paper, right? So current is moving into the paper, conductor is placed between these two poles. And in the second diagram you can take the reference that how it is placed. You can also place conductor like this. So there are different variations that how we place conductor between the magnetic field or between the magnetic poles. So that is a different concept, and that we have to study that how we are able to identify the direction of the force. So basically there is a concept of force over here because we have a current moving into the conductor and there is already a magnetic field. So what happens due to the interaction of magnetic field? So the interaction of magnetic fields of the wire and the permanent magnet, because now we have two magnetic field. One magnetic field is like generated from this permanent magnet. One field is generated from this permanent magnet and second field is generated by the conductor. So you can see these red circles shows you the second magnetic field. So now we have two magnetic field, and when these two magnetic field interact with each other, so definitely there will be some change in the direction of the conductor. So when the interaction of magnetic field of the wire and the magnet creates a force, so it will create a force on the conductor. And this force is perpendicular to both the direction of electric current and the magnetic field. So basically, we have three things. We have magnetic field, we have electric current, we have force, and all have their own direction. We know that magnetic field is from north to south. So definitely from left to right, it is moving from north to south. So that is the direction of magnetic field. And electric current is on z-axis because that is into the paper. And force is on y-axis because force is applied in downward direction. So in this way, three quantities are on three different axes. So it means they are mutually perpendicular to each other, right? And you can also identify that idea from this left hand. You can see all three quantities are perpendicular. This force is perpendicular to this magnetic field, also to this direction of electric current. So all are making 90-degree angle with each other. So all are perpendicular to each other. So this is one more important thing. And now if we want to identify the unknown quantity, like if we consider the left hand rule. So in the left hand rule, the thumb represents the force on a conductor, and in the previous right hand rule, this is completely different. In right hand rule, we have only the finger curl and the thumb direction, but this time we have thumb, first finger, second finger. So this is completely different from the first one. So in this, we use the thumb for the direction of the force, as you can see in the picture also. And the first finger shows you the magnetic field, and the second finger shows you electric current direction. And all quantities are represented in the diagram also. Represents force, first finger represents magnetic field, and the second one shows electric current. And you can also memorize these terms in the form of like term FPI, force, magnetic field, electric current. F represents force, B represents magnetic field, and current is represented by I. So in this way, you can memorize this term FPI, that for the thumb, we have first force, and then second we have magnetic field, and third we have electric current. So in the diagram, you can see we already know about magnetic field because magnets are placed. So definitely we know about magnetic field. That magnetic field moves from the north pole to the south pole. And secondly, we know about the direction of electric current. So the known quantities are magnetic field and current. So these quantities are the known quantities. And for the unknown quantities, we have force because we derive force from this concept or from this diagram. So force is unknown quantity. So this left hand rule helps you to find out the force on the conductor. And the case of the application, we use this idea of left hand rule in DC motor. And we also discuss the whole concept of DC motor. So DC motor is the application for Fleming's left hand rule. And if we compare with the right hand rule, so in right hand rule, what is the difference from the left hand rule? That we use thumb for applied force, right? If we are using a conductor, so we actually move that conductor in any specific direction. So when we move conductor, so definitely we apply some force. So we represent the thumb to represent that applied force. And then we have first finger, so definitely first finger shows the same magnetic field. And second shows current. And again, this can be memorized with the concept of FPI again. So let's suppose in question you find that that any conductor moves between the magnetic field. So in this case, we use right hand rule, and if the current is passing through the conductor and we have to identify the force, so then we have to use the left hand rule. So now the known quantities in right hand rule are the applied force, So applied force is the known quantity in right hand rule, and magnetic field. So these quantities are known quantities, and for the unknown quantities we have induced current. So in result we are getting the current, so that current is unknown quantity basically. And this concept we will discuss in AC generator. Okay, any confusion in left hand and right hand rule concept? So
No, sir.
yes,
Uh,
for
Sir,
hmm,
to confirm, the application case for the left-hand rule is the direct current motor, and
yes,
for the application case for the right-hand rule is the alternate current generator.
yes. So
Okay, okay, thank you.
in power plants we use that AC generator to generate electricity. So in that we use the concept of right hand rule, and the normal motor we used in our daily life. So that is the application of, or that is the case of application of the Fleming's left hand rule. So this is the basic difference, that where we have to use the left hand rule and when we have to apply the right hand rule. So this will help you to understand the difference, that known quantities are different in both cases and unknown quantities are also different in both cases. So definitely if they ask about induced current, so it means you have to apply right hand rule. And if they are asking about any unknown force direction, so it means you have to apply left hand rule. So this is the difference. And let's suppose if we continue with left hand rule, because in this electromagnetism, we are going to continue with left hand rule, and right hand rule will be applied on AC generator, that is the part of electromagnetic induction. So these are some examples for left hand rule that we already discussed in the diagram. So in diagram, we observe that we have a magnetic field line from north to south. So from north to south, we have magnetic field lines, and we have magnetic poles on both sides, and current is moving into the paper. So direction of the force is downward. And let's suppose if we mark this one as the first figure. So according to the first figure, let's suppose if you want to use with this left hand rule, if we want to apply this left hand rule on the first figure only, so let's suppose if we start first from the magnetic field. So from left to right, magnetic field moving is from left to right. Okay. So you have to open up your first finger, and first finger is pointing towards right hand side. So for the first diagram, this one, if you want to use the left hand rule, so we have to open up the first finger, and that first finger shows you direction from left to right. So you have to open up your first finger like this. And then we have second finger. So second finger is into the paper. So into the paper means what will be the direction of the second finger? So for the direction of the second finger, we have to use that second finger for electric current. So for electric current, what we have to do, your second finger will be towards your screen, right? Like this. That will be on Z axis. That is moving into the paper. And for the third one, Sorry, it will be thumb. So definitely thumb indicates in direction. And if you want to use this left hand rule, so there is very a basic concept to use this left hand rule. I will show you also. So in different examples, in different diagrams, you have like a different direction of magnetic field. In second, you can see the force is out of the paper. And in the third one, we have magnetic field from right to left and then from left to right. So in this way, we have different direction. So let's practice these directions also, that how to use that left hand rule to set your direction according to the diagram. Okay. So if we continue with the concept of the recording, or with the concept of the application of the direction of the left hand rule according to the direction of magnetic field, according to the direction of electric current. So for this figure, we know that we have to open up our first finger. So this direction is inverted for you, right?
Yeah,
Okay.
it is.
So when you use your left hand rule, so it will be like this. This is your direction of electric current for the first finger, right? And for the second finger, that direction of electric current is downward. So you have to open up your finger like this. Okay. So this is your first finger to show the direction, and this is your second finger for the direction of electric current. And when you open up your thumb, right? So you can see this is your thumb, and that shows you the direction. This is the direction of thumb. So that shows you the direction downward. So basically this first finger, if we consider only the first finger and the thumb. So first finger is on x-axis and thumb is on y-axis, right? Like if I use the thumb like this, so thumb is on vertical axis and this first finger is on x-axis, right? So by using this idea, current is actually moving on z-axis into the paper. So in this way, you can set your left hand rule, right? And let's suppose if we consider for the second one, let's suppose this is second diagram. So for second diagram, you have to set your fingers again. So this is the direction of magnetic field again, right? From left to right. And then you have to open up the second finger for the direction of electric current. And what is the direction of electric current? Into the paper or out of the paper?
It's out of the paper, right?
Out of the paper, because there is a pointed line, so it shows you out of the paper. So when current is moving into the paper, so we use this direction, z-axis. But now it is out of the paper, because let's suppose if you place your notebook on your table, right? So your table is horizontal. So this direction shows you into the paper, right? So this second finger is going into the paper of your book, right? And if you reverse the direction like this, so now this finger shows you that it is coming out of the paper. Okay. And when you open up the thumb, so you can see that thumb shows you direction in upward, and this second finger shows you direction out of the paper, and the first finger shows you direction of from north to south. So in this way, you can set your left hand to identify the direction of the force. Okay. So you can see force is acting in upward direction and magnetic field is moving from north to south and current is moving into the paper. Okay. And same happens with the third and the fourth if you reverse the direction. Okay. So if we reverse the direction, so what happens actually? Let's suppose this is the third one. So for the third one, we have to set the magnetic field. So now this is the magnetic field, right? This is the first finger, and this first finger is moving from right to left. So this is moving right to left. And what is the direction of electric current? Into the paper or out of the paper?
For the second diagram,
Third one, this one,
okay, for the third one, it's into the paper.
right? So it is into the paper. So now we have to set the second finger that shows you into the paper. So into the paper means again like this, downward. Basically, this is downward, but this is Z axis, right? This is going into the paper like this. And for the thumb direction, now when we open up the thumb, so again, thumb shows you direction, upward direction, right? And if you reverse the direction, so it will be like this. Okay. So in this way, you just open up these three fingers perpendicular to each other, and you can rotate according to the orientation, right? So this is the concept of left hand rule. So in this way, you can use left hand rule, right? To identify the direction for any specific question. Okay.
Right.
So very simple, you just start with your first finger, right? Because North Pole or the magnetic poles are already given. So from that north to south, you can identify direction very easily. Then open up your second finger to set the direction, because now we know what is the meaning of into the page, what is the meaning of out of the page. And this into the page and out of the page like this, like when on the desk, when you have your notebook. So according to that notebook, if your finger is moving towards your notebook, so that means into the paper. Your finger is moving into the paper. But if your finger is moving away from that notebook in upward direction towards the, like in the direction of the roof of the room, so it means that is out of the paper, right? So this is the concept. And let's see what are the other concepts. And let's suppose if they ask something like to increase the value of magnetic force, right? If we want to increase the value or the magnitude of force, they also ask the question like if you want to increase the force on the conductor, so what are the factors? So the factors are very simple,
Increase the magnetic field and the magnetic
right?
field.
So the first factor is very simple. If you want to increase the force according to the left hand rule, you know that magnetic field and current is a known quantity. So it means you can change the magnetic field or you can change the value of electric current. So that will also affect the final force. So according to this idea, we can say, just like you mentioned, use a stronger magnetic field. And that stronger magnetic field can be generated by using a stronger magnet. Using a stronger magnet, we can generate a strong magnetic field. And the second one,
Increase the value of current.
increase the value of current. And the third point, that use a long
Increase the
wire.
number of wires.
Yes. So you can use a long wire or like to increase the number of turns of the wire in the magnetic field. So you have to use a longer wire in magnetic field. And we know that when if the charges are moving from one point to another point and there is magnetic field, so they also repels in the direction. And this concept we discuss in the nuclear physics. So in nuclear physics, we discuss this idea. Let's suppose if we have magnetic field into the paper. So this is the magnetic field into the paper. And let's suppose if we use proton, neutron, and electron. So proton deflects in the upward direction. And if we talk about electrons, so electron deflects opposite direction of proton. And finally, the electron moves without any deflection in a straight line. And this is the same concept that we discussed in the nuclear physics, because in nuclear physics, we have alpha, beta, and gamma. Alpha positive, gamma neutral, beta negative. And we also discussed that those radiations can also deflect in the magnetic field. And this magnetic field is in downward direction. So this magnetic field is in downward direction. And according to this idea, we can easily identify that what are the direction of proton, neutron, and electron. Okay. And we also know that proton deflects less because proton is heavy, and electron deflects more because it is the lighter one. And it shows you for the neutron, it is completely neutral, so definitely it will move in a straight direction without any deflection. Okay. So these are some concepts related to the left hand rule. And now you can apply this left hand rule on the questions also. Because today we are not able to complete the concept of the DC motor. Because in application, the DC motor is the application of this electromagnetism. And DC motor, you can see it is also like the same setup. Same setup means we have north pole, we have coil in the center, we have south pole on one side, we have north pole on the other side, and we also use a battery for electric current. And this is commutator segment. We are talking about this. And this is another commutator segment. Basically, commutator is like divided into two parts. So we can write commutator segment. And on the other side, we have also the same commutator segment. And this part is called the carbon brushes. This is one carbon brush. And on the other side, we have another carbon brush. And this coil is actually called armature. So this coil shows you the concept of the armature. And this commutator segment is also called split rings because they are not completely connected. There is a gap between them. So that's why it is also called split rings. So the components of the DC motor, the first component is, if we talk about split rings, so the concept of the split ring is they are able to flip the direction of current in coil when coil crosses the vertical position. And we will also discuss that what is the problem with this vertical position, because we know about left hand rule. And when we apply left hand rule on the motor, so then we are able to identify that what is the concept of this split rings in the DC motor. And we know armature is simply a coil. We know that magnet that produce magnetic field. We know battery produces the electric current. And second component, which is completely different, which is called carbon brushes. Because in exams sometimes they also ask about that what is meant by the carbon brushes, what is meant by split ring. So for the carbon brushes, they are made up of the graphite, just like the tip of the pencil. And they also provide us sliding contact. They provide us sliding contact between things and external circuit. So this is the main idea of the split rings and the carbon brushes, that why we use split rings, why we use carbon brushes. And now the only part that is left out, which is called the working of this DC motor. So in our next class, we will continue with the working of this DC motor. Okay. Because now if we start, so we are not able to end it up. So the working is only left out, and we also discuss that what is the concept of that vertical position and why we are using split rings for that vertical position. So inshallah, in our next class, we will continue with the working of this DC motor, and that will be the last concept for this electromagnetism chapter. Okay.